our sine and cosine for this. So we have our unit circle, and when we have our unit circle, we've got a radius of 1 here, and then this point here has an x coordinate and a y coordinate. When we're doing our sine theta, we always do opposite over hypotenuse. So I've redrawn this one over here with our 1 and where the adjacent and the opposite would be in relation to that theta or our angle. So when we look at that, our opposite side is going to be the y value from your coordinate, and the adjacent side is going to be the x value. So if we're doing opposite over hypotenuse and our hypotenuse is 1, because that's our radius, that means that the answer to that is just going to be the y value of that coordinate. Similarly with the cos theta, if we're looking at the adjacent over hypotenuse and we've got our x value over 1, then the cos of the angle is just going to be the x value of that coordinate, assuming you're in the unit circle with the radius of 1. So having a look at a couple of questions with that, we've got some examples here where we have t equals 0. So we want to locate where that is on our unit circle. Now if we've got t equals 0, it's over here. When we look at our sine t and cos t for that, our sine t we established in the first one was our y value. So if we flick back, you can see we wrote over here our y value for sine theta. So our y value here is going to be 0 because our coordinate here is 1, 0. Up the top here would be 0, 1, just for in the future. Over here, -1, 0, and down here, 0, -1. So over here, our y value is 0. Therefore, sine of 0 is 0. If we're looking at cos, that's where we're looking at our x value. So our cos theta is going to equal 1 because our x value is 1. If we then go to 3 pi on 2, 3 pi on 2 is down here. We've got our x value and our y value. So our sine theta is just going to be -1 and our cos is going to be 0. So in this case, we're using t, so I should have put a t there. So sine t was equal to our y value, which is going to be -1, and our cos t is going to be 0 because that's our x value. Then we've got -3 pi, so that means we're going around, so we're going backwards around the circle, 3 pi. So if we go this far, we've got 1 pi, 2 pi, so -3 pi is over here. So looking at our x value, we've got -1, so that's our cos t, and our y value is 0, so that means our sine t is going to be -1. Then we've got our -3 pi on 2. So if we've gone round, that will bring us around the pi up to -3 pi on 2 is going to be here. So then our sine t is going to be our y value, which is 1. So I should have drawn that up the top here, sorry. And our cos is going to be the 0. So we've got our cos t is 0. If we've got 57 pi, we need to work out where that's going to be on our circle. So we obviously have 2 pi. We'll have done one full cycle around. So if we do 57 divided by 2, we've got 28.5. So we know we've gone round 1, 2, 3, up to 28, and then half, which means it would bring us round to here. And then we can say that our cos of theta is going to be our x value, which is going to be the 0, and our sine theta is our y value, which will be -1. We can also check these on our calculator. Obviously, we need to make sure we're in radians. So I'll go to my mode, change to radians because I was in degrees. And then when we put them in here, we can do our sine of 0 and see that it equals 0. We can do our cos of 0 and see that we get 1. We can put our 3 pi on 2 there, so we can go sine of, and I can put it in my bracket, 3 pi, whoops, try that again, sine of 3 pi divided by 2, bracket, and see how we get our -1, and then cos of 3 pi on 2, and we get our 0. So we can go back and check them if we want to on our calculator after we've answered those questions. So hopefully that helps you with your sine and cos of your trig functions.